So previously we have learned what is machine learning. In this lecture, we are going to learn why we need to use machine learning. So first of all, if I ask you a question that write a program to block spam emails, how would you do it? So you might be like, let me write some key points here. You might check for some words in the mails to filter the mail as spam or not, like some words like free, some free offers, some words like related to credit cards. uh, s- we might look into the sender's information, so we might look into some words which are based on these things. That's actually how we started while building some programs which can filter out the mails whether they are spam or not by manually creating rules. But what if the spammers change their tactics? They use some other words which we haven't written rules in our program. So that is where the problem comes. Writing manually the rules will be a limitation. So there is where the ML comes into picture, which changes the game. It learns it on its own the patterns in the data. So we don't need to manually code it. So that was the limitation of the traditional programming, that it was rule based and very rigid. So what we needed something which can examine a lots of spam emails to spot the patterns, some kind of certain keywords. So writing rules based on that is something which is very limited, because if the spammers change the tactics, then we need to change the rules on its own, and we will get a huge list of hard coded rules, and it's very fragile, hard to update, and we can't change those rules to some new tricks. Okay. So the second approach was that ML learns the data patterns automatically. So how ML works, we have thousands of examples which are labeled as spam versus not spam. We feed those examples to the ML model, that is the learning algorithm. The model learns the patterns from that data, like which word combos often show up in the spam. Then you test it, update the training data, and improve the performance of the ML model. So the benefits of this is that we have very fewer rules to write. Like we don't need to write the rules. It is like we need to write the code for that algorithm, which is very easy to maintain as well. We don't need to hard code the rules for the spam or not spam. We just need to write the code for the ML algorithm, and often more accurate than the rigid traditional algorithms, and can adapt over time also. So that is the main thing. That is what comes under the third point, adaptability over the time. As I mentioned, if the spammer switch from writing some specific words from for you to like this, then you don't need to change the rules. In traditional programming, we need to hard code this trick, but in ML, it can detect these changes automatically, as I mentioned. So this is the advantage of using ML. So ML tackles such problems without writing any clear rules. We don't need to write the rules, and ML learns from examples on its own. And it also helps the humans to understand. It helps the humans to identify some hidden insights or patterns which we can't identify on our own. It can improve our understanding of problems through data mining. Data mining is a concept of understanding the data to understand what are the underlying patterns. So ML learns from examples. Instead of we writing the rules, we provide lots of examples, labeled examples. The model finds their own best way to distinguish between spam versus not spam. So that is the main reasons why we need machine learning. I'm going to identify the key points one again. Whenever you have a manual coding problem and it becomes very difficult or complex and unmanageable, then we need ML. In those cases, we need ML. What if we don't have any clear algorithm for the task to perform in hand? Then we go for ML. When the environment changes very frequently, you need something which is more adaptable as a solution, then we go for ML. And when you want, let me process, when you want to discover patterns from large data and gain deeper insights, which as humans, very difficult for us to do. So if we want to discover patterns in large amount of data and get some insights based on that data, ML comes into picture. So all these are the applications. I'm going to give some applications like if we have too many rules to write manually, for example, in case of spam filters, we use ML. Fraud detection, we use ML. Recommendation systems, because recommendation is different for every new client. We can't have some specific rules which can work for all. So, too many rules to write manually in these scenarios. Some other examples, let's suppose we don't have any clear algorithm. For example, in case of recognizing the human speech, we can't have any specific rules in this case. Or you can also call it as handwriting. Most of them like handwriting is not understandable. In my case also, I don't know whether you will be able to understand or not. I'm trying my best. Okay. So another scenarios where the environment is changing very constantly, like in case of stock price prediction, the environment is not that predictable. In case of adaptive traffic systems, also we don't know whether it is how much time we need to fix a rule for red light, green light. And in case where you have some large messy datas, where the human might miss some patterns, large data sets. So all in all these cases, we might need the ML. I'm going to write the highlight points here. Too many rules. If you need, go for ML. No clear algorithm, go for ML. No, like you can say environment, no fixed environment or environment changes constantly, go for ML. And large data sets is its own category. So all these problems, ML is perfect in these cases. So I have covered all the points which I mentioned here. See you in the next lecture.